Today we are going to discuss about the Legendre's linear equations. So any differential equation of a specific form will be called as the Legendre's linear equation. So let's consider uh, the type of the equation. So any equation of the following form. So that is a2 into this is ax plus b the whole square into y double dash plus a1 into ax plus b into y dash plus a naught into y is equal to the phi of x. This format, if you can see any equation, then that equation will be called as Legendre's linear equation. Okay, so here we need to convert this into the linear constant coefficient differential equation. So to convert this into the required format, that is LCCDE, we will make the following substitution. Always we put the log of ax plus b as a t. This means e to the t will be the ax plus b. So now let's first calculate what is dy by dx. Dy by dx can be written as dy by dt into this is dt by dx. So dy by dt we don't know, we'll keep as it is, dy by dt. Multiply this with dt by dx. So we know that t is equal to log of ax plus b, which means its differentiation will be 1 by ax plus b into a. So I'll move the denominator to the other side. That means ax plus b into dy by dx will be equal to a dy by dt. So if we make a substitution, d is equal to the d by dt, then from the above equation I can say that this implies the ax plus b into y dash will be equal to a capital D times 1. Okay, so this will be our first substitution. Whenever I can see in my given Legendre's linear equation, if I find out ax plus b into y dash, that will be a times capital dy. Now in order to obtain the next terms, I will differentiate once again. Okay, so when we differentiate this once again, you can see the product on the left hand side. Ax plus b is a function, y dash is a function. So differentiating this implies, I'll differentiate once again, keep ax plus b as it is, differentiation is y double dash plus y dash as it is, differentiation of ax plus b is a. So ay dash will be equal to, so I am differentiating the whole function with respect to x. So a is a constant. This is d by dx of, see, dy is nothing but this is dy by dt. Okay, so now how to get the substitution for d by dx. D by dx can be written as d by dt into dt by dx. Okay, so only the RHS I'll substitute. This is okay, let's write the constant a first. This is a times d by dx. I'm going to write as d by dt of the term dy by dt into, this is the dt by dx, the chain rule. We'll apply this. Okay, but I know something already. This is equal to a times, see, this is d by dt of dy by dt, this is d square y by dt square into, see, the dt by dx we already know, right? That is a divided by ax plus b. Okay, on the left hand side I still have ax plus b times y double dash plus ay dash. This is equal to this. Now what I do, I take the denominator on the right hand side, that is ax plus b will be moved to the other side. So whenever we multiply that to the other side, this is what I am going to get, that is ax plus b. Already there is one term, I am getting multiplied by another term, so ax plus b whole square into y double dash plus, there is already a and this is ax plus b times y dash is equal to a square d square y by dt square. Okay, so this is nothing but, so already we know something, we'll substitute that, that is ax plus b the whole square into y double dash plus a into, see, what is ax plus b into y dash, that is nothing but a times capital dy from equation number 1. This is equal to, I can write this as a square, so d by dt is nothing but capital D, so there is a d square y. So we'll keep ax plus b the whole square into y double dash on one side, remaining terms I'll take to the other side, that is a square, this is d square y minus a square dy. So I can rewrite this as, I'll keep a square outside, this is d square minus d times y. So what is this? This is equal to a square into, I'll take a d outside, so d into d minus 1 times y. So that's what is the required term. So this is ax plus b the whole square into y double dash will be called as this term. Okay, so this is equation number 2. So wherever we see ax plus b whole square plus y double dash, we are going to substitute a square capital D into d minus 1 into y. All right, in the same fashion, we can actually derive the further terms as well, but just to save time, let's write down the other terms. So I'll write similarly. We can write the ax plus b the whole cube into y triple dash can be written as, this is a cube into d minus 1 into d minus 2 times y. Okay, so if you see ax plus b power 4 into the 1 2 3 4 fourth differentiation of y, that could be a to the 4 d minus 1 d minus 2 into d minus 3 times y. So we use these equations to get the solution of the Legendre's linear equation. Okay, so let's start solving the problems based on this concept. Problem number 1 is 1 plus x the whole square into y double dash plus 1 plus x into y dash plus y is equal to sine of 2 times log 1 plus x. So as we know now, this belongs to the Legendre's equation, because I can see ax plus b, same thing repeating everywhere. Ax plus b is 1 plus x, 1 plus x, right? That has been substituted everywhere. Okay, so now in order to simplify this, our the trick here is to use put t is equal to log of 1 plus x. So this implies if you write e to the t, this will be equal to 1 plus x. Okay, now let's write the substitutions as well. So 1 plus x whole square y double dash becomes a square d into d minus 1 into y. Okay, so let's make a substitution now. So this implies the same equation becomes 1 plus x the whole square. Instead of that, I'm going to write a square. A is 1, so that is 1 into d minus 1 times y, plus second term, that is 1 plus x y dash, is a times d into y, correct? So a is 1, so this is just d into y, plus the last term is y. This is equal to, so sine 2t. So this implies, let's simplify this further. This is d into d minus 1 plus d plus 1 into y is equal to, this is sine 2t. So this is d square minus d plus d will cancel. Then we have plus 1. So the equation ultimately reduces to d square plus 1 into y is sine of 2t. Right, so we can directly go for the auxiliary equation, that will be m square plus 1 equal to 0. Right, as we know now, the m is nothing but root of minus 1, so plus or minus j. So roots are complex conjugates. This implies the yc can be directly written as a constant into, this is cos t, plus another constant into sin t. Let's call this as equation number 1. All right, so to find the yp, I'm going to use the phi of t divided by f of d. So phi of t is nothing but, it's on the right hand side, that is sine 2t divided by, this is d square plus 1. So my simplification will be replacing d square by minus of a square, so that will be 4. So that implies yp will be, this is sine of 2t whole divided by minus 4 plus 1, that will be minus 3. This is the yp. So we can write the final answer, that is y is equal to yc plus yp. So yc was c1 cos t plus c2 into sin t. Then we had minus, this is sine 2t by 3. Right now we have the equation in terms of t, but what we have to do is we need to convert this back into x. So this is c1 cos. So if you have a t over there, you are going to substitute as log of 1 plus x plus c2 into sine of log of 1 plus x minus, this is sine of 2 into log of 1 plus x whole divided by 3. This is the final answer. All right. Now we go to the second problem of the day. This is a statement. Two x plus 1 whole square times y double dash minus 6 into 2x plus 1 into y dash plus 16 times y is equal to 8 into 2x plus 1 the whole square. So we make the substitution, put t is equal to log of 2x plus 1. This implies the e to the t is 2x plus 1. Right? So the substitution is pretty straightforward now. So if you see a 2x plus 1 into y dash, what will be our substitution? It is a is equal to 2 times dy. Similarly, if you find a 2x plus 1 the whole square into y double dash, this will be a 2 square, so that is 4 times d into d minus 1 into 1. Okay, in every case the capital D will be a d by dt, so we have to remember this. All right, let's proceed now. So using this, in the above equation we can write it as, so this will be 4 times capital D into d minus 1 times y. Okay, then there is a minus 6 into, so 2x plus 1 into y dash is nothing but 2 times capital dy. Okay, plus 16y, this is equal to 8. So 2x plus 1 is nothing but e to the t, so this is e to the 2t. So this is nothing but 4d into d minus 1 minus 12d plus 16 times y is 8 into e to the 2t. Okay, so I can actually cancel the terms over here. So 4 gets cancelled, this becomes 3, this becomes 4, this becomes 2. So once we simplify, we get, this is d into d, so d square minus d minus 3d plus 4 times y is equal to 2 into e to the 2t. So this means d square minus 4d minus plus 4 times y is equal to 2 into e to the 2t. Okay, so this means we can go to the auxiliary equation directly. So the auxiliary equation will be m square minus 4m plus 4 is equal to 0. So this means it is a perfect square. So m minus 2 the whole square equals to 0. So m becomes equal to 2 comma 2. So as the roots are real and repeated, we can write the yc as, what is yc? This is a constant c1 plus c2t into e to the 2t. This is the first half of the solution. Now, in order to find yp, we will write the function phi of t divided by f of t. So phi of t on the right hand side, we had 2e to the 2t divided by the function is nothing but the d minus 2 the whole square. I have to substitute d as a. So a is equal to 2, so put this is 2. So this means the denominator becomes equal to 0. So as soon as the denominator becomes equal to 0, multiply by a t, 2t into e to the 2t divided by differentiation. Differentiation is 2 times d minus 2. So this 2 and 2 will cancel. Once again, I need to put d as 2. So as soon as you put d as 2, this gives denominator is equal to 0. So my next option is multiply by one more t square e to the 2t divided by differentiation of d minus 2 with respect to d is 1. So that means the yp is equal to t square into e to the 2t. Call this as equation number 2. Okay, so now we go to the final part of the solution, that is to write y is equal to yc plus yp. So yc we got as c1 plus c2t into e to the 2t plus t square e to the 2t. So we'll bring the equation back in terms of x. So that will be c1 plus c2. What is t? T is equal to log 2x plus 1. Okay, plus I need a t square, so that will be log of 2x plus 1. I need to square this whole square. This whole function gets multiplied by e to the 2t. So what is e to the 2t? In that is e to the 2t will be my mistake, 2x plus 1. Okay, so that is I'm going to multiply this into 2x plus 1 is e to the t. There is a e to the 2t, so this is getting squared. Is the final answer. All right, let's go to the next problem. That is 3x plus 2 whole square into y double dash plus 3 times 3x plus 2 y dash minus 36y is equal to 8x square plus 4x plus 1. Okay, so first make the substitution. That is t is equal to log of 3x plus 2. This implies e to the t will be simply 3x plus 2. Okay, so this implies if I find a 3x plus 2 times y dash. I'm going to replace this as a, that is 3 into dy. Also, if I find a 3x plus 2 whole square y double dash, I'm going to replace this as a square. So 3 square, that is 9 times d into d minus 1 into y. Okay. So I have okay, on the RHS I can see that it is 8x square plus 4x plus 1, correct? So this means I need to substitute for x in this case, right? So we'll write that x is equal to e to the t minus 2 by 3. Okay, that is e to the power t minus 2 by 3 is every x. Therefore, what we do now, we'll substitute for the given equation. So first term becomes, this is 9 times d into d minus 1 times y plus 9 times, this is d into y minus 36 times y is equal to, see the first term on the RHS is equal to 8x squared. So 8, x is just above, it's a square, so there is 1 by 3, it becomes 1 by 9 into, this is e to the t minus 2 the whole square, this is the x square. Then the next term is 4x, so we'll write here, this is plus 4 times 1 by 3 into e to the t minus 2, and the last term is plus 1, so we'll write a plus 1 over here. Okay, so on the left hand side I can write this as this is, I'll write the terms like this, 9 into d minus 1 plus 9d minus 36 into y is equal to, so let me expand this term, this is 8 by 9 times, it is e to the 2t minus 2 into 2, 4 into e to the t, this is 4 e to the t, 2 square, which is 4, first term. Then the second term is 4 by 3 into e to the t minus 2 plus 1. So this is 9d square. Okay, I can say take the 9 outside. So 9, let it go outside. So I am left with d square minus d plus d will cancel. So minus 4. So this is d square minus 4 times y is equal to, so let me add the terms containing e to the 2t, that is only one term I have. So this is 8 by 9 e to the 2t. Okay, then the next term I have to club the terms containing e to the t. So there is minus 4 into 8 by 9 plus 4 by 3. That becomes minus 20 by 9 into e to the t. Then let me just club the constants, that is 8 into 4, 32 by 9 plus 4 by 3 is plus 17 by 9. Okay, let me write the equation in the following format, that becomes easy for us to solve. This is d square minus 4 into y is equal to 1 over 81, this 9 goes to the other side, into this is 8 e to the 2t minus 20 e to the t plus 17. Okay, now we got the equation. So in the next step, we'll write the auxiliary equation. This is m square minus 4 equal to 0. So this implies m is equal to plus or minus 2, right? We have two answers. One is plus 2, one is minus 2. So roots are real and distinct. So as soon as we get real and distinct roots, yc can be written as constant into e to the power first root. So that is 2t plus another constant e to the power second root into t. All right, so this is equation number 1. We got yc. Now let's go for yp. Yp is the function of on the RHS in terms of t divided by the f of t. So that will be function on the RHS is 1 over 81. I'll keep this as it is, into, that is 8 into e to the 2t minus 20 e to the t plus 17 divided by, that is d square minus 4. So the solution is in 3 parts. Let's do this in the following fashion. So the first term is 8e to the 2t divided by d square minus 4 minus 20 times e to the t divided by d square minus 4, and the last term is plus 17 divided by d square minus 4. Okay, we can see that it's the type 1 of solution for LCCDE. If you have e to the at by f of d, a has to be substituted for every d. Okay, so I'll make a substitution here. So put d is equal to 2. So here you put d equal to 1, and for the last one put d equal to 0, because 17 is e to the power 0t. Correct? So this is 1 over 81 into, I know that when I put this d is equal to 2, so 2 square is 4, 4 minus 4 equal to 0, so denominator becomes equal to 0. So my solution is 8 multiplied by a t into e to the 2t divided by d square is 2d. Put d equal to 2. So this cancels this as 4. Next, minus 20 e to the t divided by, this is 1 minus 4, so that is minus 3 in the denominator. So this is plus 17 by d equal to 0, so this becomes minus 4. Okay, so this is 1 over 81. Now I need to put d equal to 2. So this is 4 e to the 2t divided by d is 2. So 2 cancels with this as another 2. Sorry, I missed a t here, so I'll write a t here. Okay, 4t. So now this becomes 2. This is plus 20 by 3 e to the t minus 17 by 4. After simplification, 1 over 81, this is 2t e to the 2t plus 20 by 3 e to the t minus 17 by 4. This is the yp. So we know that how to write a final answer. Y is equal to yc plus yp. So we will put it back. First, let's write the answers as it is. Then we'll write the answer in terms of x. So this is c1 e to the 2t, c2 e to the minus 2t plus 1 by 81 times 2t e to the 2t plus 20 by 3 times e to the t minus 17 by 4. Okay, this answer is in terms of t, but I want the answer in x because the given statement is in the form of x. All right, so let's substitute that. So C1 as it is, e to the t is nothing but ax plus b. So 3x plus 2 square plus C2. See, this is power is minus 2. I can write it in the denominator. So that is 3x plus 2 the whole square. If this term goes to the numerator, then the positive power. Okay, that is plus 1 over 81 into 2 into t is log of 3x plus 2 into 3x plus 2 the whole square plus 20 by 3. E to the t is nothing but 3x plus 2 minus 17 by 4. This whole thing is the required answer. That finishes the concept of differential equation and solution of differential equations. Let me know if you have any other doubts. Thank you for watching.